all. My name is Aleksandar. I'm a senior .NET developer at ENDAVA. I'm passionate about IoT world, and today I will speak about technologies that are shaking the world. But first, I will start with explaining what is IoT. Most of us think that our toaster should look like this, have an antenna, display it, will be smart and connected to internet. But IoT presents a system of interrelated devices or humans or even animals that have unique identifiers, and they are able to transfer data over the network without requiring human-to-human interaction or human-to-computer interaction. In the Internet of Things, a thing, as I mentioned, can be a human with a heart monitor implant, or an animal with a bionic transporter, or a car with a sensor for tire, and they have public IP addresses. They can transfer the data over the network. This coin of words, Internet of Things, was introduced in 1999 by Kevin Ashton. He's a co-founder at Auto ID in MIT Center, and at that time he presented the Internet that the only source of data was human, and that source of data has its own limitation. You know, the human was producing data by typing on a keyboard, by scanning a barcode, by pushing a playback button, and the limitations were that the human needs to sleep, for example. So the time, the accuracy, the attention was not there yet. For that reason, he introduced the Internet of Things, and those can be replaced as the technology comes. But in 1999, that was not the first attempt of Internet of Things. It was early 80s at the Carnegie Mellon University. A group of students decided to connect the Coke machine to the internet and to check if there is a cold Coke instead of going to the Coke machine. We have a lot of application of the IoT world, and the reason one that I came across, it was very interesting for me. They put the cameras on the billboards, and they scan the people that are looking at the billboards. For how long they will look at the billboards, what's the ethnic group that is looking at the billboards, and from that they're doing an analysis, and they can do a much better marketing. Another example that we have, I believe now in Macedonia, is the traffic lights. If it's more traffic, they will be much shorter in a time, or if there is less traffic, the time will increase. Now I will present the stack of IoT. At the bottom level, we will see there is a sensing of the data. That's the thing that is doing in the IoT world. The above level is data integration, where we structuring the data, building the models, and on top of that is the level with analysis of data, where we need to analyze data, extract information, and give an answer. Giving an answer will be in a cognitive way. That's the top level. So now I will continue to explain what is a cognitive IoT. Unfortunately, at home I don't have a fridge that will say to me, stop, it's enough. If you want to start a diet, just turn the fridge to the wall and cognitive. When you say cognitive, it's thinking. It's a process of thinking that divides us, the humans, from everything else. And we know that by Turing, the computers cannot think. But they can do several things, like they can understand, they can reason, they can learn. Understanding the data means they can gather data, they can structure the unstructured data, they can reason from the data, so they can build models and extract informations, and from that information they can learn and behave differently over the time being. So those are the processes that we are interested in, and I will present several showcases, successful stories in a cognitive way. Sitecore is a CMS that brags about the omni-channel connection with the end user. So they have also user profile and personalization. And they wanted to introduce a new interface with communicating with the end user and the CMS. So two guys were bored at work and decided to build Robbie. They revealed Robbie 3 or 4 months ago. I was on a Sidecar conference and they revealed it there. Basically, Robbie is an IoT thing. It's a robot that can speak with you. It's built with cameras, speakers, servos, and LED matrices. The hardware part and the software part is Windows IoT Core operating system and cognitive services, Microsoft Cognitive Services. Robbie's abilities were to detect face. It can detect face, multiple faces. It can track your face, your movements, and it can detect your emotions. By doing that, if he will see that you are sad, for example, he will send that data to the Sidecar CMS, and the Sidecar has a profile for you, have pool of jokes for you that will brighten up your day. And it will tell you the joke in using Luis. Luis is a language service from Microsoft. So face recognition, face tracking, emotion detections were the things that he can do. So that's one of the interfaces presented, but that's a global example. So we have two successful stories here at ENDAVA Skopje that we we promoted that are working. The first one is voice scheduling assistant built with Alexa. You know, we have in the companies, we have conference rooms, and we want to book that room to have a meeting with the colleagues, and we want to see if that room is available. So we need to open Outlook to see all of the rooms, to see all of the people's, what they're doing, and that requires time. But when you enter the room, you can say to Alexa, hey Alexa, is this room available at that time? Yes, it is, please book it for me. That means that Alexa can recognize your voice. And also, you don't need to break your tongue in Macedonia. Every one of us has a different dialect of English. So it's a natural speech recognition service. The other one is tracking ships that can go into pirate waters, and they need to notify the client. And we implement GPS module with Raspberry Pi connected with Azure and Service Bus event, and there were subscribers and seeing in the real-time data where the ships go. This is everything is okay, beautiful, nice, but you have concerns about IoT world that we need to present out into the world. Those concerns are mainly a hacker, not a legal one, can either attack the insulin pumps, so the health devices, either spy on our home, or the latest example was with the last movie, Fast and Furious, where they can control all of the cars. And that problem came first of all from the client-server paradigm, where everything is sent to the server. So every IoT for the first needs to communicate with the server, needs to send a lot of data, needs to process a lot of data, that server, and that infrastructure and the scalability are very costly. And at every life cycle to monitor the data is very also costly. So what we can do in order to improve that or change that, we need to use the decentralized model of communicating, to have peer-to-peer communication, to have distributed file sharing among the devices, and to have autonomous device coordination. That means that we'll no longer will have a single point of failure, like one server for authorization, identification, and gathering data. All of the devices need to work with themselves. So there is a new technology, I don't know for how long it is in the world. It's a blockchain. Blockchain is a decentralized principle working, where the ledger, we can use it for authenticating, registering new devices, and for that we can know how the data is transferred, and we can authenticate the devices without fearing that those can be tampered. Thank you for your attention.